Section 4.2 is all about logarithms. And a logarithm is just a fancy way of saying exponent. Okay, so 2 to what exponent gives us 10? Okay, we know 2 squared is 4, 2 cubed is 8, 2 to the 4th is 16. So the x is somewhere between 3 and 4. Okay, and logarithms allows us to find exactly what that decimal is. Okay, so to do this, we're going to rewrite this using a log. Okay, so the base for this problem is 2. Okay, so the logarithm is log base 2 of what it's equal to 10 equals x. So again, we say this log base 2 of 10 equals x, and we can use our calculator to figure out exactly what this decimal is. Calculator. Okay, so on the calculator, we can type that in. So log base 2 of 10 is 3.3219. So x equals 3.3219. So to check this, let's do 2 to this exponent, make sure we get 10. So 2 exponent is 3.3219. We get 10. So again, a logarithm is just a way for us to solve for exponents when we do not know what they are. Okay, so I guess a formal definition when a to the x power equals b, then that means log base a of b equals x. And we could go backwards, starting with the log. We could write it using an exponent. So what is this going to look like for us? Okay, so the last time we met, we looked at this formula. No. So the compounded interest formula. 1 plus r over n into the t. So the log can help us figure out what time it takes to get a certain amount of money. Okay, so let's say if we start with $5,000 and we're growing at a rate of, let's say 1%. and it's compounded biannually, so twice a year. So n equals 2. How long will it take us to get $10,000? So we're just going to plug in everything we know. Our amount is 10,000. Our P, our starting amount, is 5,000. Our rate is 1%, 0.01. N is 2. 2 to the t. So how long is it going to take us, if we start with 5,000, will it take us to get to 10,000? Okay, so we're just going to start off, figure out what this is in the calculator. So 1 plus 0.01 divided by 2, 1.005. So 10,000 equals 5,000 times 1.005 to the 2t. So we need to get the part with the exponent by itself. So to do that, we're going to just divide both sides by 5,000. That cancels it out on the right. So on the left, we're left with 2. And on the right, 1.005 to the 2t. Okay, now for us to solve for this exponent, we're going to use logs. So rewriting this using a log. So our log, our base is 1.005 of what it's equal to, which is 2, equals our exponent 2t. Okay, now our goal is to get t by itself so we can figure out what time is. So we got one more step, divide everything by 2. Okay, now using our calculators, we're going to figure out what this decimal is. 69.49. So that's how many years it would take us to get $10,000 if we started with 5,000 and grew at a rate of 1% compounded biannually. Okay, there's one other thing we need to look at with logs, and it's the natural log, ln. It just means the natural log. And this is just a special log that has a base of e. So if you remember the last time we met, we said this number e was kind of like pi. It's just a number that is 2.71828, continues on. So anytime we see a natural log, it's just a log with a base of e. Okay, so a problem that uses natural logs. Let's say we start population in a town No, the projector turned off. So let's say the population in a town is currently 3,000. And it's decreasing continuously at a rate of, let's say 3% each year. So our continuous formula, A equals PE to the RT. Okay, after how long will it take the population to reach 2,000 people? Okay, so our amount is 2,000. Our starting amount was 3,000. Our base is E. Our rate is a decrease at 3%, so minus 0.03 times t. So our goal is to solve for t. So again, we want to get the part with the exponent by itself. So divide both sides by 3,000. And you should get 0.6 repeating, 2/3. Now that we got the part with the exponent by itself, rewrite this using a log. So this will be log base E of 0.6 repeating, 2/3, equals negative 0.03 t. One more step to get t by itself, we got to divide by this negative 0.03. So t equals, remember we said the log base E is just natural log. So the natural log of 2/3 over negative 0.03. And we'll use our calculator to get that decimal. So the natural log of 2/3 divided by negative 0.03. So just in the calculator, 13.52 years. So if we started with a population of 3,000, decrease at a rate of 3% each year, after 13.5 years, there will only be 2,000 people in the population. Okay. Hopefully this wasn't too confusing for you.